Okay, so I'm going to explain the theory of relativity as simple as probably is possibly can. So the theory of relativity is related with space. What is space? Space is the space, you know, the area where items of universe are placed. And what is mass? Mass is the density of a space, meaning everything in in a universe is part of the space. Sun is part of a space. Earth is part of the space. But depending how dense that mass is, the denser that mass is condensated. Imagine a ball of iron comparing with a feather. There is much less atoms in a same area of space as opposed to ball of iron. And so density of that items is directly related with the mass. Mass is not a density, but I mean the feather pillow. Let's say a huge pillow can have the same mass as a ball of iron if the ball of iron is small, right? And it would have the same mass, same kind of stuff stick together. That's the mass. Okay. Now, if we shrink that mass in Earth, we don't see that, but in universe, there is proven that the ball of item compared to pillow is nothing if you compare that super dense masses in some parts of universe when they are so stick together that is like thousand or million times more than the atoms and molecules of ball of iron are stick together. Okay, so that's when the black holes are formed. That's where the universe, as we can see, as we can understand, ends. Then it goes, we don't know where our universe ends. Like imagine if there's a two-dimensional like being, he will not understand if there's a three-dimensional, you know, stuff because it goes beyond their, reality. And the other thing we have to consider is time. So universe not only have a place when events are staged, okay, but it also has a time where those events are staged, are kind of sorted, meaning is a space the event can happen here, right, or can happen here, but event here can happen like this, right, or it can happen like this. So time is a sequence of events. Okay, speed of time is how sequence of events follow each other in what rate. But time, we will talk about the time goes, time becomes faster or time becomes slower, meaning in some places of universe the time can go like this, meaning sequence of events, every event that includes how people think, how people act, the reality, basically reality as we perceive, can go like this. But in some area of the universe, it can go like this. And basically, uh, I mean, the way the second, imagine that you watch this video. If you watch this video on 0.25 speed, as opposed to times 2 speed. You can do that, right? The same way in universe, depending in certain factors, things can happen like this or it can happen like this. And okay, and the time velocity, I already told you what is this, the velocity. And the speed of light. Speed of light is a, um, speed of light. Let's say we put a flashlight, or you are flying on airplane, you see a lightning. You can track the lightning of airplane if airplane high enough. I remember when I was flying to Europe, I saw the lighting, and that lighting kind of immediately transfers through one part of the globe to another, because I could see the curvature of Earth. But I could see, like in split of a second, it went from one part of the globe to another. Same way you can track like say this is the Earth, right? This is the Earth and this is the Moon. Speed of light, 1, 2, 3. This is 1 second, right? So let's start. 1, 2. So this is Earth, this is Moon. One. When you say 1, 2, it's already here. Same way, speed of sound. Same way, if you saw flying, you saw the curvature of Earth, you saw lighting, you could literally see speed of light in split of second. It just goes from one part of the Earth to another. The speed of light. Okay, so here, when these interact, okay, and the mass, also there's a gravity. I didn't put gravity, okay, but let me put it. Okay, so mass, gravity, energy. Okay, yeah. So these mass, gravity, and energy are proxies of each other. Okay, the more dense is the particles, the more energy it has. And Einstein even came up with this like a famous theory. Energy equals m, let's say, times, because I don't want to put the regular way, because time speed of light times speed of light, which is the same 300,000 kilometers per hour times 300,000 kilometers per hour. It's a big number, but it is exactly the Q, I mean, not the Q, but square of light. Square light times square of light, meaning um, if you are driving your car 60 miles per hour, and then you want to measure something, you don't multiply 60 miles per hour times 2 or 3 or 100. You multiply your 60 miles per hour by the same 60 miles per hour. Okay, so so space depends. So everything here is interdependent. So that's the whole theory of relativity. First of all, I want to say, because many people get confused, I got confused about this. Okay, so I'm going to go over this really quick. In Newton theory, in Newtonian the mechanics, when it says if there is a ship, or if you are in a train, right, and someone is on a not train, when you move on a train, there is no difference. You move in a train as opposed to that person doesn't move, stays there, as much as that person moves towards to you. The same without any difference is you move towards to that the person. Here that's not the same. Universe is not the same. So in Newton, let's say is a train or is a car, right? If this car moves 100 miles per hour and you are staying here, from Newtonian mechanics law, there's no difference. You are in the car or you are this person. But how come it's not difference? The car is moving, but you are staying, right? But here in Einstein theory, there's a big difference. Okay, so the relativity, if there is something non-relative in Einstein theory, it can be confusing because the only thing in Newtonian mechanics which was mentioning relativity is movement is the same, right? But here is not the same. So here in Einstein theory, it makes more sense, is much more intuitive, correct? In Einstein theory, let's say there's a space shift, right? If spaceship moves with speed, and then you are staying here or moving around your galaxy like little bit like this, like we are moving around the sun is moving around our galaxy, but let's say there's a spaceship by 3/4 of the speed of light move like this, does not the same. From the perspective of spaceship, we are not the same as from the perspective of someone inside a car or inside a railroad train as opposed to someone there. So that's not relative. If something moves, it moves. In this theory, uh, so you can move. You can move fast or you can move slow. Okay. So depending how fast something with a mass or without a mass, we can come to that, moves from the space, meaning gets transferred through the space when stuff is located, known and unknown to us. Okay? Then the passage of events, meaning time, changes. So this is really, if you understand this, then it's intuitive. If you change this part, meaning if the space gets changed, I mean, when the velocity, okay, when the velocity of movement in a space changes itself too. We don't see it, but when you see this, it should be meaning, let's say there's a space shift, right? The spaceship moves speed of 3/4 speed of light, okay? And we are here like complete losers on our Earth, right? Then when this spaceship moves like this really fast, and we are just they're hardly moving, right? Then the time, meaning events happening to the spaceship, still events are happening way slower as opposed to us. It includes the if there is a um, you know captain in this spaceship, the way he thinks, how he thinks, everything, including thought, including blood flow, everything. So all this blood flow, all our thoughts are part of the space, part of those creation. Right? So I mean, our thought. I mean, we don't need to be megalomaniac and delusional. Think our think is above the space. Everything. I mean, we are nothing compared to this space, right? Or maybe something little, or whatever. We can't even understand it. But when those parameters change, these changes too. Meaning, and then from the perspective of this captain on the spaceship, the the whole universe becomes like this. It gets shrink. Okay. Every not only he sees that the universe gets shrink, or his spacecrafts get shrunk, right? It becomes like this. it's not like it seems to him. It doesn't seem to him. That's how it happens. Okay, that's us real for him, as it's real for us. Actually, we are part of it. Okay, I mean the extent our time works and our universe is shrunk or not shrunk depends how fast we move, because we do move. Okay, and when we go when we go to the speed of light, if we can, and then our mass has to become zero. Okay, so there's a direct connection. If something goes to speed of the light, its mass has to become zero, because everything becomes velocity. That's the ultimate speed on space. I don't want to confuse you, but just a hint. The space we see, our three-dimensional space, there is a physics that suggests that speed of light can be surpassed if we are getting out from this, you know, area, meaning it is our three-dimensional space. If we get out four dimensions or find something, then we can. But let's put it aside. I don't want to confuse. Okay, so the mass becomes zero when you go speed of the light. Speed of the light cannot be more. Okay, it's 300,000 kilometers per hour. I mean, you probably know if you are watching this. It's 1 second from here to the moon, and mass must be zero. Everything has to be velocity. If this happens, I don't want to leave only this correlation, since everything here is correlated. Okay, so when we go to the speed of the light, okay, let's say it's our galaxy. Uh, Imagine this part is our galaxy. And then if we go speed of the light, it's going to be on a space scale, it's going to be so slow. But let's say we are not going on a space scale. Let's say this is not a galaxy. Let's say this is a couple of solar system. Okay, if let's say go like this, then from the perspective of someone with consciousness, but without a mass, let's say people in the future created a humanoid or artificial intelligence which can be placed on this speed of a light, which has a zero mass but has a consciousness. Then what happens with this space? It becomes like this. Virtually becomes zero. Meaning, what happens with the time here? Time stops. So if we go speed of the light, nothing happens. It just stops. For centuries, for millennia, for billions of years, nothing happens from their perspective. If they go, let's say, 3/4 of the speed of the light, time passage is so slow, meaning if we can create this kind of spacecraft, they will go circle around. We can stay here like a complete losers. Millennia can pass and it can come only maybe 10-15 year pass, depending on equations. They came up with these equations. They can exactly calculate those numbers. We don't, I mean, we are not about it. We are understanding the concept. And the same happens, similar stuff happens when the mass becomes really strong, when things inside the state are so, you know, uh, tightly coupled together, right? Well, how can I? Let's say this is the space. It becomes like really dense. When you change the density of a space, right? Then it becomes the gravity, meaning gravity, the way it attracts, it pulls matter near to it, becomes very big. And again, similar stuff happens. Time passage slows down, right? and when time passes slows down, then and the space shrinks too. It gives the similar effect as opposed you move faster through the space. Meaning all this stuff matter, all this stuff was related, and that's how I mean you can understand theory of relativity of Einstein.